Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this Techstrong learning experience brought to you by Firefly. My name is Cody, and I'd love to welcome you back to Techstrong Learning, where we have another exciting program ahead. Before we get this ball rolling, I do have a couple of housekeeping notes I'd like to review with you. First of all, today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch at a later time or share with your team, you will be receiving an email with a link to access the recording on demand. Now, if you'd like to engage with us, ask questions, say hello, there's a couple of ways for you to do so. For any comments or general chats, we do want you to use the chat tab. So I see a lot of people already checking in, and I'd like the rest of you to let us know from where in the world you are tuning in. If you have specific questions, please direct your questions to that Q&A tab. Sending your questions to the Q&A helps us keep organized, and we want to be able to answer as many questions as we can today. So send them into that Q&A tab, and we'll try to address them towards the end of our program. We do have a poll today, so I'm just going to quickly launch it. It should pop out on the side of your screen and let us know how familiar you are with infrastructure as code, whether you're beginner, intermediate, or advanced. I'll also prompt this about halfway through our program today, so if you have already answered it now, feel free to ignore it later. And my final note is, before we close things out today, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of our conversation today. So our topic is lessons learned from writing thousands of lines of IAC, or best practices for creating and using Terraform infrastructure as code. I'm joined today by Sefi Janis, co-founder and CTO of Firefly. Sefi, thank you so much for joining me today. I'm going to hand the floor over to you.
Thank you very much for having me, Cody. That's my pleasure being here. And thank you very much, everyone, for joining. So I'm Sefi Janis, CTO and co-founder of Firefly. And the main session today is best practices for writing and coding infrastructure as code. In this session, this talk, I'll walk you through the trajectory of the infrastructure as code, and then I will discuss and flip the script technically about best practices and what we should do and shouldn't do regarding IAC. So before that, I'd like to explain about my company, Firefly. Firefly is a cloud asset management solution that scans the entire cloud footprint, hyperscalers like AWS, Azure, GCP, etc. We scan SaaS applications and Kubernetes, of course, and we also analyze the infrastructure as code. I mean, all IAC tools from Terraform to Crossplane. So what Firefly does is to reduce the cloud complexity by detecting the discrepancy between the cloud and the IAC. We detect drifts. For example, if somebody deployed something with Terraform, but somebody else changed the configuration manually, we codify resources using Terraform modules, etc. And we also help govern the cloud. We built many policies code for FinOps, SecOps reliability. And that's Firefly in a few minutes. And let's talk about IAC. So I'll start with the trajectory. And before starting this, feel free to ask questions here in the chat. I'd love to hear some questions. As you can see, in the last few years, we started to see many infrastructure as code tools. It started with Puppet and Chef. Today, it's Terraform, Pulumi, and Crossplane, etc. And I brought here a diagram for Google Trends that you can see that around 2019, this is in rise. I mean that many companies in the world adopted IAC because today that's de facto the only way to manage the cloud complexity. And I will touch this point a lot at this talk. But before that, I would like to get back to before 2011 to the pre-cloud era when companies adapted their own data centers. Companies hired IT departments to manage the servers, to manage the machines in their on-prem. The main infrastructure as code tools then were Chef and Puppet. Both of them are infrastructure as code tools, agent-based IAC tools that can deploy security patches, etc. And that was very expensive. Managing this operation was very expensive. And that's why around 2011, we started to see that companies migrate some of the on-prem to the cloud. The main hyperscalers, AWS, Azure, GCP, they launch services for compute and for storage like EC2 and S3 bucket. Azure launched Azure Blob Storage and the equivalent for compute, etc. We started to see that companies adopted Ansible. Ansible was the first agent-less infrastructure as code tool that enables to install resources using the vendor's API instead of installing any agent. And in order to protect our cloud, we saw some solutions, runtime scanners like CSPM, Security Posture Management, that detects misconfiguration for public accessible assets, users without MFA, security group that might be open to the entire world, etc. And the second thing is cost optimizer. I guess that most of you heard about Cloud Health or Pileus or other solutions. All of those solutions can detect misconfiguration for FinOps, like detecting GP2 EBS volumes that should be migrated to GP3, etc. But around 2015, 2016, we started, I call it, by the way, Cloud V 1.5. We started to see that companies broke the monolith into microservices. And the main technologies were serverless, like Lambda function in AWS or the equivalent in Google and Azure. And of course, Kubernetes. And the main reason, the main driver for using those technologies is the reason that companies broke their monolith into microservices, and the hyperscalers built their own infrastructure as code tools. I mean that most of you heard about CloudFormation, first YML, YAML-based infrastructure as code tool that can deploy resources in the cloud, like Lambda function with the role and policy attached, etc. And that's the first immutable infrastructure that we can define how our resources should look like and deploy them in multiple environments. Okay, and of course, that Helm chart was created by the community and it's very famous, very popular for Kubernetes. And around 2019, I call it Cloud 2.0. That's the first time that we see de facto companies adopt multi-cloud. And this diagram, we in Firefly, we made the survey and we asked many DevOps teams about the cloud adoption. And you can see that multi-cloud is a real thing. It means that most of the companies in the world use more than one cloud provider. It could be multi-cloud or AWS, Google, Azure, other clouds, etc. And that's why we started to see that many companies adopted Terraform. And the reason for that is that Terraform is the first unified infrastructure as code tool. It means that we can deploy resources for our AWS and for our GCP, etc. And one more driver for using Terraform is the immutability. Immutability means that we can deploy and we can build a group of resources and deploy them in multiple environments, like prod, staging, dev, etc. And one of the drivers for that is the shift left approach. Shift left means that you remember that I told you that in the past we used some scanners that detected misconfiguration, FinOps stuff. So right now we can detect everything through the CI/CD. By the way, there are a great open source tools out there, and I'd love to elaborate on that in the Q&A, like TFSec. It was created by Aqua Security. Today, it's part of Trivi. Kix is also a great open source tool, or InfraCost that can detect misconfiguration for FinOps. It can actually calculate how much we are going to pay if we will apply our changes, etc. So shift left is one of the drivers for using infrastructure as code. And of course, disaster recovery. If we build our code immutable and we can deploy it in multiple environments, you know that every year, US East 1, North Virginia, is down for 1 day. So we can deploy our infrastructure in a new region and it improves our reliability. And I'm taking you to 2023. And we have interesting questions here because we can't know which infrastructure as code will be the dominant But the first question is the declarative versus imperative. It means that DevOps engineers, they know Terraform configuration-based languages, while engineers know imperative languages like Python, Go, etc. So if I'm an infrastructure engineer, why shouldn't I build my infrastructure with Python or Go? Why should I build it in Terraform? And that's a really interesting question. And Pulumi is trying to build an infrastructure as code tool, imperative infrastructure as code tool. I mean that I can deploy my EC2, my Lambda, my roles, etc., using Go or using Python or using JavaScript. And their main competition today is Terraform CDK and AWS CDK. Both of those solutions created a layer on top of their original solution. It means that you can use CDK-TF, you can build your code in Python, and it will be compiled to Terraform with Terraform state, with the entire stack of HashiCorp. And you can also use AWS CDK, and it will be compiled, it will be compiled to CloudFormation. I guess that most of you heard about the huge gap between DevOps and R&D. It's everywhere, and one of the approach is that the DevOps team can build the infrastructure, the modules, the generic templates, and the engineering team can use the templates and use it by themselves. So using that, that's the de facto today. I see more and more companies adapting this approach. One more interesting question is the cloud agnostic. For example, in Terraform, if I want to deploy Kubernetes clusters in the all hyperscalers, I need to create my EKS, my AKS for Azure and GKE in Google Cloud. But if I'm deploying storage, it's S3, Azure Blob Storage, GCS, etc. Why shouldn't I build one unified resource for storage and decide in which hyperscaler I want to deploy this? And that's exactly what Crossplane solves. Crossplane is the first infrastructure as code tool based on Kubernetes that can create a CRD, custom resource definition, that you can define the resources and deploy them in which hyperscalers that you choose. And that's really interesting question. And last question, and that will lead me in this talk, is the micro infrastructure. I see more and more that companies break their infrastructure into micro layers, micro infrastructure. For example, if I have one big Terraform state with many resources, of course that the provisioning time could be a long time. And that's why we're breaking the infrastructure, for example, for a layer of networking that is in charge of the VPC, internet gateway, subnet, etc., and application layers, it's ease our process. It's reduce the complexity. Super. So in Firefly, I mentioned it, we made a survey called State of ISC, and we asked many DevOps teams about their challenges and the main challenges while managing the cloud. And we all know and will see that the main challenges are knowledge, tool complexity, engineering resources, and asset visibility. And we learned from that ISC, infrastructure as code, is de facto the only way to manage the cloud complexity. There is no other way to govern the cloud. And as a result of using ISC, you will get less downtime. I mean, the probability for downtime reduces. And we see that the engineering team is more efficient, the engineering, the DevOps engineering. We also have audits, and it helps us to troubleshoot our infrastructure. That's why I'm a big advocate for infrastructure as code. And that's lead me to talk more technically, and that's why I flip the script a bit and discuss what we should do and shouldn't do while implementing infrastructure as code, and specifically while implementing Terraform. Super. Cool. So the first thing is that you should treat your infrastructure exactly as you treat your application. There is no difference. And the two main things are consistency and reusability. I mean that while coding your Terraform code, you should keep a naming convention, you should keep variable names, etc., and break your infrastructure into micro infrastructure. I mean that you should break your architecture and build your code that will be self-explained and easy to understand. And while talking about reusability, I usually talk about Terraform models. Terraform models today, de facto, is the best practice. Model, generally speaking, is a group of resources that can be deployed in multiple environments. We can configure our models with versioning. We can configure our model as we wish. And my 2 cents for you is that you should build models generic with many variables, and then call to your generic models with environment-specific values. And using that, on the one hand, you maintain a generic model, a versioned model, and on the other hand, your code is self-explained, and it's easy to understand the entire changes. I'll touch this point in this talk. Okay, this one is really important one. You should not provision any resource more than once. And why? Because sometimes we have shared resources like a VPC or dependencies, etc. And if I'm deploying the VPC from multiple workspaces or from multiple IC projects, it might affect a different workspace. And that's why, remember that I told you that you should break your infrastructure, and that's the main reason, that we shouldn't provision a resource more than once. So if we break our infrastructure to the networking layer and to the application layers, so we know that the networking layer is a single source of truth only for those resources. And my tip, and that's a technical tip, is that you can use output and data resources. So for instance, if I'm building my networking layer, I can use the output for the VPC, for the internet gateway, etc. And I brought here an example. You can see the values here, that you will see the value after running the Terraform apply command. And while building additional layers, you can use data resources. Data resource, generally speaking, is a read-only resource that can get the specific configuration from the cloud. And I'll give you an example why it's necessary. If you'd like to deploy EC2 machine with Ubuntu latest version, you need to find the latest Ubuntu version for your AMI. So using data resource, you can ask AWS to give you the specific image in US East 1, for example, and then you can use the data resource to provision the EC2 with the relevant AMI. So that's the best practice. Okay, that's obvious, but you should use remote state. I mean, I highly recommend to use S3 bucket. That's the most common remote backend. And while saving your Terraform state in S3, you should configure a deletion protection with multi-factor authentication. You should configure ACL, versioning, etc. And don't forget that the test state file, that's the brain of your Terraform. That's the last deployment. If you lose this specific file, it might corrupt your entire infrastructure. And just to give you an example, if I have a project and I already applied it and I have a Terraform state, if I remove the state itself and I will try to run the Terraform apply again, it will say you have 5 resources that are going to be added. And then I'll try to add them, but they already exist in the cloud. And we'll get HTTP 409 from AWS. And that's why you should keep them. And don't forget to back them up. I mean that with one configuration, if you use S3 bucket, you can continuously version your Terraform states. That's the best practice. I'm giving you S3 bucket, but of course there are great other tools. You can use Console, HashiCorp Console, or other remote backends. This one is also important to use state locking. I mean that if you're more than one person touching the same infrastructure, locking will avoid issues like corrupting the infrastructure, touching simultaneously the same resources. And my tip for you is don't override the lock. I mean, don't run Terraform apply unlock the locker. And by the way, the main solution today is DynamoDB. I see many companies adopted that to save the lock for Terraform. That's the best practice. That's obvious. you should never touch the Terraform state manually. This file is sensitive. This file is the brain of Terraform, and touching it is like a surgery. And that's why Terraform provides CLI commands like Terraform MV if you want to move a resource from one model to another. And if you break your Terraform state into micro infrastructure, into multiple Terraform states, you can use the Terraform import command in order to import the resources into the state, and don't edit this file manually. And document your code. And I'm not talking about comments, I'm talking about version control, about Git. That you can, I don't know which Git do you use, but I guess GitHub, GitLab, or Bitbucket, I'll take GitHub as an example. You have a versioning automatically for models. You can configure that each pull request, each commit will be versioned with a new a major and a minor version. And using that, your code will be sustainable, and you always know what happens in your code. So don't forget to document it, to use version control, and I'll touch GitOps in the next slides, because that's really important. And I think that this one is the most important slide in this talk, is that you should never save out coded secret. I know that some of you, or most of you, are engineers, and you know that you should never push any sensitive information to GitHub. So I mentioned that you should treat your infrastructure exactly as you treat your application. So don't push secrets to GitHub, and the solution for that, while talking about infrastructure as code, is your environment variables. If you have the access key for AWS, for example, you can also use Terraform variables. Terraform variables as a configuration, a specific configuration, to mention it is sensitive. I think that from Terraform 0.14, so use this specifically, and encrypt your Terraform state. And this one is also important because Terraform state might contain sensitive information, and you can easily encrypt the Terraform state by configuring KMS key in your S3 bucket that holds your Terraform states, because it might contain secrets, API keys, entropies, and other bad things. And of course, that you should use CI/CD instead of running your Terraform apply from your local machine. And I'll explain about the concept of GitOps and then how we can leverage it. GitOps generally means that while creating a pull request, it runs the Terraform plan. While merging the pull request, while merging the pull request, it runs the Terraform apply, and your master or main branch is always aligned with the latest versions. And my 2 cents for you is that you should define code owner, code reviewer, who can review, who can approve pull request. And you can do more. I mean that while running the CI, while running the Terraform plan, when somebody creates a pull request, you can run some scanners like infracost, Trivi, TFSec, bridge crew, kicks, etc. And I'd love also to elaborate on them. And using that, you know that your infrastructure is battle tested and is best practice. And I forgot that you can also use TF-Flint that can detect a naming convention for your code. And for example, if you are trying to deploy a resource in a wrong region, it will block you. And using GitOps, and I highly recommend to use Atlantis. Atlantis is a great open source tool that can leverage the Terraform orchestration through your Git. That's an amazing solution, so use it. And don't bypass the IC pipeline, and I'm talking about drifts. Drifts is the discrepancy between the cloud and the IC. Okay, because if you deploy something with Terraform and somebody changes the configuration manually, that's a drift. It might affect your production, can cause a security hazard, misconfiguration for FinOps or reliability. And that's why we should streamline our processes. And GitOps is the answer, in my opinion. And please monitor, before that, you can see that the drift looks like that. On the left side, you can see an IAM policy with a permission set. I can see list resource record set for Route 53, another permission set. And on the right side, you can see that somebody logs into the console manually and added Route 53 all. So next time you will run the Terraform plan, it will ask you to override the changes while running the Terraform apply. And monitor your drifts. And one of the ways to do that is to continuously run Terraform plan. I mean that while running a Terraform plan, we understand the changes. And if we see that the resource is going to be changed, we can send notification to Slack, PagerDuty, or other notification system. And you can also use Firefly, by the way, because we detect drifts with context, and our solution is near real time. I mean that after detecting the drift, 10 minutes after that, we'll see it in Firefly. We can also detect the context, who made it, when, how, etc., and can fix drift back to your Git. And my key takeaways from this webinar, and then I will answer any questions you have, is that you should treat your infrastructure exactly as you should treat your application. That's really important for consistency, for usability, etc. It helps you to generate a unified code and deploy in multiple environments. And the most important key takeaway is that don't push secrets to your Git and save your hard-coded secrets. And thank you very much. Before that, I will share the state of IAC. That's the report that I mentioned before. And I'm available for any questions from your side. Thank you for listening.
Awesome. So Sefi, we received a lot of questions. So let's see how many of them that we can get to today. So somebody asked in chat, can Firefly work like a Flux for the code?
Yes and no. Flux is a GitOps. I mean that like Argo CD, when you change the Kubernetes resources, Firefly is not an orchestration tool, but we bring the tooling to help you detect misconfiguration, to continuously streamline your process. It means that we will detect drifts for you. We can codify resources, but we are not actually run the Terraform apply for you. But we can detect the Terraform plan. I mean that you will be able to integrate through the CI/CD, and using that we can detect misconfiguration, block some issues while running it. Does it answer the question, by the way?
I think so. We'll have that attendee send us in a follow-up question if that was not sufficient. So we'll just go ahead and move on for now. Can you do reverse engineering of the cloud services scan and write Terraform scripts and compart with IAC and fix the issues similar to self-healing? I can actually put that on the screen.
The answer is yes. We continuously detect the cloud. We scan the cloud foot. Oh, sure. That's good. So what Firefly does is to scan the entire cloud footprint and generate the Terraform code with models. So as I mentioned, we won't touch your infrastructure. We give you the tool to continuously manage it by yourself. But our codification is sophisticated because we support models, we support dependencies, and we also adapted AI. And there is an open source tool, by the way, called AIAC. And I will share it here on the I will share it here on the chat. 1 second. That can also help you generating infrastructure as code using AI.
All right, so our next question reads, is there a way to reverse engineer what you have into Terraform?
Yes, and that's what Firefly does. I mean that by scanning the entire cloud footprint, we understand all of your resources. I mean, networking like your VPC, internet gateway, or application stuff, or cloud formation, cloud from distribution for CDN, etc. We understand the dependencies and the connection between resources. Using that's the reverse engineering, that we scan the cloud and we generate Terraform models and Terraform code that you will be able to deploy in different environments later on.
Our next question reads, what are the
Sorry, Cody, one more thing is that
Go ahead. It looks
I
like
want
we're
to
on a
mention one
delay.
more thing. Sorry to interrupt. Firefly also generates Terraform. Yeah. I wanted to mention that Firefly also generates the Terraform import command in order to import the resource into the state. So that's also fundamental in order to continuously provision resources that already exist in the cloud using IAC. So that's the technique and how it works.
Awesome. Thank you for that addition. Our next question reads, what are some best practices for sharing Terraform modules and versioning them over time?
What are the best practices for sharing Terraform models and versioning them over time? Okay. I'll answer it from a different perspective. And my answer is regarding the community models. Community models are highly maintained by the community. Of course, Anton Babenko, by the way, is one of the ambassadors of Terraform. And you can find Cloud C or other Terraform models. And the reason that I recommend using community models is because that they are highly maintained and people always fix issues, etc. And don't trust them immediately. I mean that you should understand that exactly what you use. And some of the community models are great, but on the other hand, you don't want to use a model with the suspected suspicion.
Great. Moving right along, what are some best practices for sharing Terraform modules? And, oh, sorry, I just asked you that one. You talk about multi-cloud. Is there any way to manage multi-cloud IAC, not rewriting the IAC scripts for each provider?
Depends on the technology. I mean that if you use imperative language like Terraform or imperative like Pulumi, you need to build cloud-specific resources, because that's how Terraform and Pulumi works, and that's how they work. I mean that if you want to deploy S3 bucket and blob storage and GCS, you need to create 3 different resources. I also mentioned Crossplane. Crossplane is a cloud agnostic solution that can help you generate one unified resource that can be deployed in each provider. That's also interesting approach. Each of them has, by the way, pros and cons. I don't have, there is not black and white here, and everyone should choose the right tools for him or her.
Perfect. I'm just going to pop up the next one already. So what could be the possible caveats in DevOps environment of using IAC? Does it force us to use the same deployment process, even though there may be customized configurations involved?
Okay, let me read the question again, if I may. What could be the possible caveats in a DevOps environment, of using IAC? That it forces us to use the same deployment process, even though there may be customized configuration involved. This question is a bit sophisticated. I'd love to get some elaboration, if I may. I mean, if you can give me a specific example for what you want me to elaborate, that would be great.
Perfect. So participant 128, if you can send in a follow-up to that one, we'll go ahead and answer that as well. Just making sure we haven't already received that follow-up. Okay. All right, so moving right along. We've got a lot of questions, so thank you guys for sending in all of these questions.
Sure.
Are there any recommended CI/CD tools specifically for infrastructure as code workflows? And then they also say other than Atlantis.
Cody, can you say it again? I couldn't hear you very well.
Are there any recommended CI/CD tools specifically for IAC?
Yes, there are many open source tools for orchestrating the infrastructure for CI/CD. I mentioned Atlantis because that's a great open source tool. But the truth is that you can also use your own GitLab pipeline or GitHub Actions. It's very easy to create this and to tailor-made your CI/CD pipeline. Atlantis, I truly like this solution. Of course, there are a paid solution like a Terraform Cloud, also a great solution. It's also a GitOps, but it's a paid solution. It's not an open source tool. I think that Atlantis is a great one. I know more orchestrators. There is a category called tacos, solutions that can help you leveraging your infrastructure as code and orchestrating them, like Spacelift and Zero, etc. Of course, it's easy to use them. On the other hand, you need to give your permission set to your cloud. So that's why in my opinion, that's the pros by using those solutions. And I highly recommend using GitHub, GitLab, or Atlantis, and keep your admin password and admin permission set.
Wonderful. All right, so Sefi, we did receive a follow-up. I'll put the original question up on the screen, but the follow-up information was while integrating other apps that need customization.
Hold on 1 second. It's related to the first question, right?
Yes, sir.
1 second.
Or rather, this we are calling back a question we looked at a few minutes ago. Okay. And then this was the clarification.
Yeah, give me 1 second. Just read it again. I want to.
Perfect.
Integrating other apps that need customization. I truly don't understand the meaning here in this question. I mean that I can discuss on what you should avoid while deploying your infrastructure and your CI/CD pipeline. Can you go back to the first question, please?
Yes, absolutely. 1 moment.
Thank you very much. Yeah, so I don't understand this specific question truly, because what do you mean when talking about customization? While building your infrastructure as code, you can build your models and you can build your own practices and you can use them. So of course that you can leverage your models and use customization, but the only bits that I can think about is about community models, such as don't use community models without fully understand what you use and if you have some warning signs behind. But this question, sorry, but this question is not super clear. So I'd love to elaborate, but I need to understand it first.
Yep, understood. So we'll just kind of keep moving, and we'll check back in with you, participant 128. So can you share some best practices
Sure.
for organizing and structuring Terraform code and modules?
Yes, of course. Before answering this specifically, there are some solutions, some concepts like dry, don't repeat yourself, that talks about not building any resource more than once, not copy paste any Terraform resources. And today, while using the Terraform vanilla, while using the Terraform code, you can build a generic model, generic template for your services like the networking, your application, like backend, frontend, etc. But you can use the generic models, and you can use the generic models with environment-specific data. I mean that, for example, I'll try to explain it in different words. If I have some models, generic models for each application, and I have environments, I can break this for two different directories, two different folders. And under the folder that is related to the environments, I can create a subfolder for prod, staging, dev, etc. And each subdirectory can utilize the generic model for my backend or my frontend or my networking with environment specific. I mean that, and using that, we build generic models that are highly maintained, and we can reuse them. But on the other hand, we build environment specific environment-specific models using the generic one.
Great, thank you so much.
So if I just need to elaborate on that, break it. Sure. Hold on. Sorry to interrupt. Last sentence is that you should break them into two folders, one for the generic models and one for the environment. And then under the environment, you should build your prod, staging, dev, etc. And in each one, you use the generic models with environment-specific values.
Perfect. Thank you so much for that, Sefi. Just scrolling through and looking for more questions. We've got so many that I'm having to see which ones we've answered, which ones Cindy's answered in chat. So let's take this one at random. What are the recommendations around IAC tools for interoperability of same code reuse across different cloud platforms? So they want to use IAC across more than one cloud. Are there certain recommendations or guidelines you have for that?
I see. For using the same code in more than one cloud. And it's two different things if you want to deploy it on two different AWS accounts, or if you want to use a Terraform resource and deploy in AWS and GCP, because it's two different solutions. Let's start with the first one, and then I'll talk about the cloud agnostic. If I have some resources that I would like to deploy in multiple clouds, multiple AWS accounts, that's immutability. The ability to create resources and deploy them in different environments. And environment could be deployed under dedicated AWS account or Google Cloud, etc. But it's the same code that will be used in a prod that is deployed in a cloud in a specific AWS account, and on staging that is deployed in a different cloud account. But I think that you asked specifically about the cloud agnostic. If I would like to deploy my resources in AWS and in Google, and for cloud agnostic, you use Crossplane, and you can build a generic module, generic resource, Kubernetes resource, Kubernetes CRD, custom resource definition, for storage, for compute, for permissions, etc. And then you can decide if you want to deploy it on AWS or on your Azure account, Azure subscription.
Awesome. So moving right along into our next question, how can you test your Terraform scripts even before provisioning the resources? Do you have best practices for testing Terraform scripts before provisioning?
Yes, you should always run the Terraform plan. Terraform plan command is a read-only CLI command that detects the provisioning itself. I mean, it tells you which resources are going to be created, removed, or changed. Using that, you understand the provisioning status. And on top of that, you can use some solutions. And by the way, Firefly does this as well. I mean, you can take the Terraform plan JSON file, and Firefly can detect also misconfiguration. If now you're changing the security group that might be open to the entire world, Firefly can detect it and can block your CI/CD, avoid running Terraform apply. So that's exactly how Terraform works. And before applying the code, you should run Terraform plan.
So this may not be able to be answered all in one swoop because I'm sure it's a large list, but what various tools have you mentioned in today's presentation? We've got a lot of people who do want to follow along, review this, and if we can get a list in kind of like 15 seconds, I think they'd really appreciate that.
Sure. So I'll start with an open source tool that I've launched a year ago called validIC.com. ValidIC is a best practice tool that combines multiple analyzers like TFSec, TFLint, InfraCost, etc. And you can run all of them in one place. But I'll elaborate on the different open source tools. There are many out there, but I can give you a list of the famous and the most common one. You have Trivy. Trivy is a security open source tool that was created by Aqua Security. They took the TFSec and put it inside Trivy, and that's an open source tool that can detect misconfiguration for Kubernetes and for infrastructure, both of them, like public accessible assets, if we have any EBS volume without encryption, or if we have our EC2 machine that is public accessible. You can also use Kix that was created by Checkmarx. Kix is a great open source tool because it's based on open policy, and it's very easy to create new policies, and they maintain this very frequently. And that's why, and by the way, in Firefly, we also adapted Kix, so I highly recommend using them. You also have a Chekhov, a bridge crew Chekhov. That's also an open source tool for security that can detect misconfiguration for your code. All of those tools are related to security. If we talk about linter, you can use TFLint. TFLint is an amazing open source tool because it tells you that your code was written with best practices, such as, and I mentioned some examples before, but if now I'm coding my Terraform code without the same naming convention or without best practices, like deploying on US East 3, of course that it doesn't exist and it will be failed. And that's why TFLint touch and find all of those stuff. You also have InfraCost. InfraCost is a great cost analyzer that can detect misconfiguration for FinOps, such as if I'm reproving my EC2 and I'm changing it from T2 micro to T2 4 extra large. Using InfraCost, it can show you the diff and it can show you how much you're going to pay on this specific resource. Great open source tool. I highly recommend using that. And last one is Inframap. Inframap can help you generate a map of your resources, both for your Terraform state or your Terraform code, understand the connections. And sometimes, specifically, we're talking about Azure, well, creating resources in Azure, it's complicated. Because you need a network security group that is deployed under subnet, and you need to configure some resources. Inframap can detect if you forgot any connection on or any resource group.
Awesome. Well, Sefi, thank you so much for going into depth on that. I know our audience really appreciates hearing all those tools, those extra resources. So thank you again. I've got the next question up on the screen. It kind of plays off of the previous question, but what would you use in your ideal Terraform CI pipeline?
So obviously valid IAC. I mean that we built an open source tool that can run all of them in one place. You can also start this open source tool. I'm just joking. You should check the Terraform analyzer, Terraform open source, and understand which works for you. I can tell you my recommendation, but everyone has different opinion. I really like Kix. I think that Kix is a great open source tool, and Trivy is an amazing open source tool, and InfraCost is a great solution. So if you take Kix or Trivy and you choose InfraCost, so you cover yourself for security and FinOps, or you can easily integrate your application, your CI/CD to Firefly, and then you'll get much value because we continuously govern your CI/CD and continuously govern your cloud.
Awesome. Thank you. I'm just looking for that next question. I had it and lost it, but here we go. How does Firefly optimize issues when it comes to state where execution fails somewhere and you cannot restart it from the exact same point?
Okay. So what Firefly does, and I explain it very briefly, is that Firefly continuously scans the cloud also with cloud events, and we analyze the infrastructure. It's called a Terraform state. Using that, we detect the discrepancy between the cloud and the ISC. We are in the middle between the cloud and the Terraform state. And if somebody changes the configuration, and it could be a manual change in the cloud, or the legitimate change through the CI/CD that affect any disruption or made some drift. So Firefly detects drifts. Firefly detects changes and context for changes. I mean that I don't just tell you we detect drift in your EC2 machine. I can tell you at the specific time, who made it, when, etc., to give you the full context and to fix it. So that's how it works. And because we continuously scan the cloud and we use the cloud events, so that's how that's why Firefly is up to date always.
Perfect. We're gonna move right into our next one because we are running low on time now. So how could generative AI LLM platforms change the landscape for writing and updating functional and clean IAC? Does it fit into the Cloud 2.0 heading, or is it a better fit for the future?
Okay, really love this question, and I will answer with an open source tool that we created called AIAC. I think that I shared it here, but I will do it again, and then I'll answer your question. I think that AI, that specifically generative AI, that's the way today to generate infrastructure as code with best practices. You can iterate with, in that case, for example, while using AIC, our open source tool, you can generate a new infrastructure for Lambda function under VPC with specific configuration. And if it doesn't meet your needs, you can reiterate and you can talk with the chat and ask more and more and more questions, exactly what you need. And in Firefly, we also adapted this open source tool that we built inside the product, and we elaborated it. It means that you can use generative AI, and I truly believe that generative AI, that's the answer. That's the next genification. And not just for infrastructure, also for policy as code. Using AIC, for example, you can also generate policy as code for OPA. to govern your cloud, FinOps, SecOps, reliability, etc. Or some don't even think about regex. I'm as an engineer, I didn't write regex code in the last 6 months because I used AIAC to generate it for me, or a query from a MongoDB or Elasticsearch or something like that, or building a Docker file or building the CI/CD pipeline. You can do everything today with generative AI. I highly recommend using it.
Awesome. I'm going to pop up the next one. I think this is going to be our last question for now, Sefi. How can you effectively manage the automated environment using IAC spin in and spin out? What are typical challenges and what are the best practices to handle the same?
Okay, ephemeral environments. That's a really interesting question. If you have some environments like dev environments that you have TTL tags or something that resources always being created and removed, or if you have any Kubernetes cluster that creates Kubernetes nodes or EC2 machines or something like that, everything, in my opinion, should be managed in infrastructure as code. That's the best practice. But of course, that if I'm managing the autoscaling group, I shouldn't manage the EC2 itself. And EC2, and by the way, in Firefly, we look at those resources, the resources as child resources. And that's why you should manage the top resources, the autoscaling group, the security group, etc., in order to manage them. And I think that if you have ephemeral environments, Terraform or IC, that's the only way to run Terraform apply, Terraform destroy, Terraform apply, Terraform destroy. And using that, you can create and destroy environments very easily.
Awesome. Well, Sefi, we are at the top of the hour, and it looks like we've exhausted pretty much every question we've received. So I did want to give you the opportunity to close us out. If you had any final thoughts or anything you feel should be an absolute takeaway from this last hour.
Sure. So first, thank you very much for joining. That was my pleasure. And I'd love to chat and answer any other question offline. My email is sefi@gofirefly.io. You can check out our solution. We also have free tier, and I'm available for anything for you. And my last sentence: don't forget, never push any secrets to your Git.
Of course. Yep, that's a big one. Sefi, thank you so much for joining us today. So his email address was sefi@gofirefly.io, and I did put that in the chat as well. So just a couple of messages up. But Sefi, thank you so much for not only spending time with us today, but also for enduring about 30 minutes of hard questions from our audience. So thank you so much for being here.
Thank you very much for having me.
So to our audience, just a reminder that we did record this session. You will be receiving an email with a link to access the recording on demand, or of course, you can find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section where it will be there waiting for you. So we do have 4 Amazon gift cards to give away. There's our Iman S. We're doing a live drawing, so I've got it pulling right now. So Iman S, Anil K, what is that one? Amin N, and Dan A. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should make its way to you in the next 48 hours. If you don't happen to see that email, check your spam folder just in case it happens to be filtered out. So I'd like to thank Firefly for sponsoring our program. And to our audience, thank you so much for being here. We appreciate your time, and we do want your feedback. So if you'll stick around for just a moment longer, you'll be redirected to a survey. It's only 3 or 4 questions, and we'd love to hear your thoughts. We hope to see everyone at a future Techstrong learning experience. You may now disconnect. Sefi, thank you so much.